Okay, so we're solving the October-November 2022 variant 2-2. We've already the fundamental programming skills paper. We've already solved the theory paper. If you want to check that out, please do that. It's uploaded. I had just started solving this paper actually, but then I realized that my audio wasn't recording properly. So I solved a little bit of this paper, but I'm gonna whatever were the only text kind of questions. I have already written them down, but the ones that require solving, I'll do that with you again. So, first question. A programmer is developing an algorithm to solve a problem. Part of the algorithm will be appropriate to implement a subroutine. State 2 reasons why the programmer may decide to use a subroutine. Firstly, if the task is repeated at several places in a program, you should use a subroutine. So that is our first point. Secondly, testing and debugging is easier. And another point I gave is it reduces the complexity of the program. So you can add any two of these and get the 2 marks. The procedure header is shown in a pseudocode. Procedure myproc count integer message string. Give the term for the identifiers count and message and explain the use. So these are our parameters and they're used to pass values in the procedure. Simple as that. The algorithm in part A is a part of a program that will be sold to the public. All the software errors that were identified during in-house testing have been corrected. So it is only in-house yet, nothing outside of the parent company or whatever has been done yet. Okay, so identify and describe the additional test stage that may be carried out before the program is sold to public. So it's called beta testing and that gives you 1 mark, and there's 3 marks for the description. So testing carried out by a small group of potential users. Now this is important, this bit. Users will check that it doesn't have any errors and it works properly and will provide feedback for improvement. That's it. So I'll solve this one with you all once. It's easier to understand. For this one, you're going to need to open the insert, but that's fine. I can put some screenshots here and you can follow. So this is a variable, type and values. And these are the procedures. So procedure mid is, it'll pop up right now. So basically we need a number here and a number here. We have the number, now month of the flag day, so this is 4. So it's basically right now mid char list 4 1, right? So char list is this variable. So what we do is we go to the 4th position, 1, 2, 3, 4, D, and give only one character from that. So it will only be D. If it was 4, 2, then we will give DE, right? So this is D. Okay, I didn't write that well. D. Now, integer count divided by length of char list. So 29 divided by char list का length है 1 2 3 4 5 6 6. That is approximately 4.8 something. But since it's an integer, we'll only get this 4 as the integer value. If count is greater than or equal to 29 and flag day is greater than 23, so this is true, right? Because it's 29, it's equal. True, and day flag day. So 23 is not greater than 23, right? So this becomes false and our output will be false. Moving on. An algorithm will process data from a test taken by a group of students. The algorithm will prompt and input the name and test mark for each of the 35 students. The algorithm will add the names of the students with a test mark less than 20 to an existing text file, support list.txt, which already contains data from other group tests. So you have to write the steps in just English steps and not pseudocode. Okay. So first is you have to open this file in append mode, right? Because we're adding stuff to the file, right? So we have to open it in append mode. Then we have to prompt and input the student name and mark. So we'll ask for the thing. Now what we're doing is you they ask for name, mark, and then you check if mark is greater than 20. If it is not, it goes ahead to write the thing. If it is, then it directly skips to step 5. Step 5 is this. So step 4 is write only name to the file and repeat from step 2 35 times because there are 35 students in this group. Simple as that. Moving on. Explain why it may be better to store the names of the students in a file rather than in an array. So when you store it in an array, every time you rerun it, you'll have to every time you run the program, you'll have to re-enter the data. In a text file, you don't need to do that. So no need to re-enter data when program is run. Explain why write mode cannot be used. Because if you write in the write mode, the existing text will get overwritten. So you say, so that existing file doesn't get overwritten. Simple. Alright, I'm going to solve this one with you as well. Just going to erase that real quick. Okay. So we're starting here. State 1 and then input A. So we're going here. Input A, output X. And next state is state S2. Then we say it remains at S2, which means this one is being carried out. So input A, no output, and we go to S2. Next, output W, which means we're going here. So input B, output W, and next step is S3. State is S3. Next thing, output is W, which means we're going here and not here. So input A, output W, and S4 is our state. Moving on. A stack is used in a program to store string data which needs to be accessed in several modules. A stack is an example of an abstract data type. Identify one other example of an ADT and describe its main feature. So you could either write about queue or linked list. I wrote about linked list, but both can give you marks. So the features are each node contains a pointer and header. So this is your node. It has a pointer for the next node, which leads you to another one, and the data of that pointer. A pointer to the start of the list, and the last node has a null pointer so that it won't lead to anywhere. That is the last node. Simple. Explain how stack can be implemented using an array. Now this is a string data stack, right? So declare a 1D array. So it should look something like this. So it has to be a 1D array, and it would be a string 1 for this. So the number of elements that we want in the stack, the number of elements in this array should be equal to the required stack, size of the required stack. Okay, so if there are 35 students, we need 35 elements in this array. The pointers and variables are initialized to indicate an empty stack. So it is an empty stack in the beginner. Each stack item is stored as an array element. So each of this will be stored as an array element, right? Now you can also describe the push and pop function. Push will add an element to the top of the stack, and pop removes the element from the top of the stack. Okay, I'll solve this one with you all again. Okay, so first one, this is the initial state, and we can just rewrite this because y, x. Okay, then what we're going to do for group 1, we have to push E first, so it just adds to the top, and then you push, you have to push D first, my bad. Push D first, then E, and this is where our pointer will be. Then after group 2, we pop 3 out. So from this we pop all of these out, right? So we have P, Z, Y. SP is here, but you always write these back up because it doesn't delete it. It just means that if something is pushed here, it will replace this and not be added here. So we have to push A, push B, pop, and then push C. So P, Z, Y. Now we can, whenever we push, it will come here. So push A, push B, and this remains the same. But, so first the SP is here, but we also have to pop one out and push C. So you pop one out, SP goes here, and then you add C here, and your SP becomes here, right? Which means it will just be like this, A, C, E, but your SP is here. That's it. Okay, now we can move to the fourth question, and I haven't solved further, so let's move together with this one. A program flowchart represents a simple algorithm. So it starts, you input user ID, set average to get average user ID, okay. Then set total to 0, index to 4. This is just initializing. Okay, is index less than 7? No, then you do this. If it is, then set last to this. Okay, so there is a preconditional loop being used here. Right. Yeah, so there is a precondition loop. So we have to write a pseudo-code to represent the algorithm. Okay, anyway, let's start. So to begin with, you have to input user ID. So that is just going to be simple. Input user ID. Then we have to set stuff. So we'll just do that. Average. I'm just setting stuff to whatever they've asked us to do. Total is 0. Index is 4. Moving on. So we can either use the while loop here or we can use the for loop here for this one. I'm gonna go with the while loop. So while the index is less than 7, repeat. Okay, so if it is less than 7, so we go here. So then we carry on over there. Then last, so we same month. Okay, hold up. Yeah, so set last to same month index. Simple. Moving on. Then there is another, we can use a simple if condition, if loop here. Then if average is greater than last, then total is, so we just add average to the total, right? Okay. Else total will be the, otherwise we add the last to the total, right? Okay. See, so add average or add last, anyway. So that is done, and we'll have to end if here, and we have to increment the, we have to increment the index. So index is +1. Now we have to end this while loop that we started. while this is that. Oh, we'll also have to add until index is equal. Okay, until. So I'm running out of space. I'm just gonna write here. Until index equals 7. And we also have to call this procedure right here. So we're gonna call it call update. Yeah, so this is it, the whole code. Give the name of the iterative construct in the flowchart. So since this you're already beginning with a condition, it is a preconditional loop. Yep. Examine the following pseudocode. A programmer wants to rewrite the pseudocode as 4 separate if-then-end-if statements, each containing a call statement. This involves writing a single simplified logic expression as the condition in each statement. Okay. So first, if A is true, then if B is true, then if C is true, then you call sub. Else, call sub to end if. Okay. So that's simple. We want A, B, and C to be true, right? So we can just use the AND statement for this. So if A and B and C, then call sub. Okay, wait. So, sub 1, right? Yeah, we have to call sub 1. Now, okay, the whole point. Else, call sub 2. Okay, so if A and B are true, then we're calling sub 2, right? So we just end if here. So we want only A and B to be true. If A and B and not C, because we want C to be false, and not C, then, oh sorry, I didn't write this in caps, then call sub 2, end if. For sub 3, now if B is true and C is true, then so B and C, then we call sub 4. Okay, so if A is true, which means here A is not true and B and C are true, then we call C sub 4. If A is not true, okay, so first we can, for the fourth one we can finish that. So if you see ahead as well, if C is false, right, so which means B is else mein chal raha hai, right? So if B is false and C is false, then we call sub 3. But if C is true, then we call sub 4. Which means we just need C to be true to call sub 4. Makes sense. So, and also A should not be true. If not A and, oh wait, this is the, if not A and C, then call sub 4 end if. And to call sub 3, we need B to be true. For sub 3, if C is false. So you see C is false here, and obviously starting wala A to false hai, which means we only want B to be true. But the main condition here is C and A should be false. So if not A and not C, then call sub 3. This was a nice question. I've never seen this kind before. So yeah, that's the answer for this. Moving to the next one. Okay, a factorial of an integer is a product of the integer from that number down to 1. In general, factorial is n into n minus 1 till 1. For example, factorial of 5 is 5 into 4 into 3 into 2 into 1. Okay, in this question, n will be referred to as the base number. Okay, a function find base number will be called with a positive non-zero integer value as a parameter. Return base number if the parameter is a parameter value is the factorial of base number. Okay, return minus 1 if the parameter is not. Okay, parameter is not a factorial. Okay. Okay, so if they give 120 and if it is a factorial of something, we give what number it is. So 12 is not, so you give minus 1. Okay. Okay, so basically we have to get a parameter value. So usko x ले लिया suppose. So this we have to input, right? Don't go over my pseudo. This is not pseudo-code. I'm just writing for notes. So you input that. If they give you 720, then you have to output 6. If they give you 600, you have to output minus 1. Okay, so if it is not, it's like squares. If it is not a perfect square, then you return minus 1. But this time we're looking at factorials. Write pseudocode for this. Alright, let's start. First we'll start with declaring our function. So let's give the value as a parameter, and that will be integer. Okay, and this returns also integer because either it will be minus 1 or it will be the actual answer, right? So, and it returns integer. Moving on, so let's just declare our other variables. I'm just gonna leave some space for the declaration and move ahead, right? So how I'm thinking we should do this is, suppose you get a value of 120, right? Now what we want to do is basically start with 1 and then multiply it by 2, check if that's equal to 120, or then multiply it by 3 and check if it is equal to 120, and keep checking until we get, and at 1 into 2 into 3 into 4 into 5 it will be 120, and at this point we want to give this number. So each time we add 1, it has to be a variable. So let's give that variable as we for sure need 2 variables, so I'll declare that. Declare number and try both as integer. Okay, so we'll have to multiply that. So starting from, we should initialize or not. So let's initialize try to 1. That's better. So try to 1. Alright, so now First, we also have to check. We are trying to multiply try and num, right? That is how we're going to get our answer. So, okay, we're going to keep checking until. Let's just check until our number becomes our value, right? Because it's always going to be smaller. So, because if let's do that. So I'm going to put a for loop here. For number is between 1 to value, right? So our try, so try becomes try into num, multiplied by num. Now if try is equal to value, then base number found. Else, let's not do else. Base number is found, and we'll also have to return okay, so num will be our, like if we find 720, so 6 will be the num, right? So we'll just return num. And let's end if and next. So we can increment our number. अगर ये नहीं हुआ till value, if this doesn't happen, we can just return -1 and we end function. This is the final pseudocode. Cool, moving on. A program is written to allow a user to input sequence of values to be checked using function. The user will input one value at a time. The variable used to store the user input has to be of type string, because the user will input end to end the program. Valid input will be converted to an integer and passed to base number and return this. Complete the table by giving 4 valid strings that may be used to test distinct aspects. This is testing. So first we give a non-numeric, I'm just going to write my name, a non-numeric string value, and it is not end, right? So only if it is end will the program actually do something about it. So why do we choose this? It's non-numeric string value that is not end, right? Next we can try to put okay, so we can put -3. Now this is never going to be correct because it's a negative integer. So non-positive integer. We can try a decimal, numeric, but not integer. And lastly, we can just empty, because string you can also have an empty string. So these are 4 that we can do. Moving on. A teacher is designing a program to perform simple syntax checks on programs written by students. 2 global 1D arrays are used to store the syntax error data. Both contain 500 elements. Error code contains integer values and represent an error number in range of 1 to 100. Error text contains string values and represent an error description. Okay, so a following diagram shows an example of the arrays. So error code and error text. Alright, There may be less than 500 error numbers, so corresponding values in both arrays may be unused. Unused elements in this have the value of 999. The value of unused elements in error text is undefined. Okay. Values in error code array are stored in ascending order, but not all values may be present. For example, there may not be an error code 31. Okay, so cool. There is no organization whatsoever, but okay. The teacher has defined two programs. We have to write for output error. So first one takes two parameters as integers, a line number in student's program, an error number, searches for the error in error code array. If found, outputs. Okay. If not found, outputs the line number and a warning. Okay. Okay. Understood. Cool. So moving on. We have to write a efficient pseudocode, meaning that there should not be any loops unnecessarily running on our thing. Okay. So let's start with calling our procedure, declaring the procedure. And what do we need a line number and we need an error number. So let's get those. Line number, error number, and they're both integer. Okay, let's declare. What do we have here? We'll have to have an index because there will be incrementation. We'll be incrementing, so let's declare a index and let's leave some space and and index will be 0 at the first. Okay, so let's use a repeat loop here because we have to increment the line. So repeat index becomes index plus 1 until so error code, right? We have this. So error code, we'll run that onto the program, right? Yeah. So we'll run our error code program onto the index. If it is greater than or equal to the error number, yeah, we can run it until that. Or index reaches 500 because it is a 500 element array. So we'll run this and we're incrementing index by this, right? Now we run a if loop, right? If error code equals errnum, sorry, not errnum, we have declared it as err, this one, right? Errn, then we have to output the thing, right? So output err text, that is the global array of the index. So let's just look at the format. So this is the thing, online and then the number. Okay, so online and then line number. That's that. else output unknown error on line num. Okay, and we end if here and procedure. You can pause the video and look at this code once again and try to understand it better. If you have a doubt, leave it in the comments. Write an efficient bubble sort algorithm for the sort arrays. So bubble sort is like 90% chances of a bubble sort being in the paper, so you want to be sure with that. There is a very simple way to remember a bubble sort. If you want me to make a video only about that, let me know. So let's declare our procedure at least. Procedure. Even if you don't know what to write, keep declaring the procedures and all, because that could get you one mark everywhere, and that's enough. Declare sort arrays. Now, for bubble sort, there are some variables that you're most definitely going to require. So, in this, let's just first read. Sort the arrays into ascending order of the error code, right? So, we're going to need temp declare then we'll also need a variable that reads through all of them. So I'm not going to go very deeply into bubble sort just yet, because I'm thinking of making another video on that. If you want that, let me know. But okay, so you need a variable. I'm just going to take r and temp r, and we need, so it reduces, so we can just do index. Okay, and all of these are integer. Okay, we'll also need to check for swaps. This will be Boolean. So there are 500 of those, right? Okay, so we have to run this 499 times. So we have to run our index. Let's set index to 499, and we have to run that 499 times, one less than the boundary. So we'll use the repeat loop. Repeat. So we want our swaps to be false. Then for j is 1 to index, right? Because I told you to run it 499 times. So if error code of r, right? Yeah, if error code r is greater than error code of r plus 1, which means if I have suppose, so r is just the position, right? So if suppose we have 30 and 20 like this, and we want it in ascending order, so we want it to be 20 and 30, right? So this is our r here is 1 and r here is 2. So if r of 1, that is 30, is greater than 20, it is, right? Then what we do is we shift them, so we have to swap them, so we have to change. So temp, you just load error code r into that. So this goes into a temporary, and our r1 goes into r plus 1. and then error code r comes r plus 1, right? So now this is swap. Now we put temp into r plus 1. And do we also need to sort the text? Arrays. Oh, arrays. So we also have to sort the text. So we'll need another temp. So we make this temp 1 and temp 2 will be string. Right? Okay. Moving on. So we have to look at temp 2 को भी switch कर लेते हैं. So same way. Instead of error code, we're doing error text now. Temp 2. So इस पे temp 1 लिख लेंगे. Yeah. That's good. So that is done, and then so once we've swapped, we'll have to make swaps as true. So swaps becomes true. Now we end if. Oh wait, we'll have to. This is inside the if. So there. End if, then next r, right? Yep. Next. Oh, I have written j here because I am referring to the ms wherever I need to be sure, and they have used j, which is why I'm getting confused. But next r, and index we'll increment. Index becomes, sorry, increment, decrement. So index becomes index minus 1. Why are we decrementing? Because we started at 499. We could always start at 1 and then stop the code when it reaches 499, but that is just not as convenient. So we're just going to do this minus 1, and we have to repeat this until there are no swaps. So like once all of them are in ascending order, so you get 10, 20, 40, 60, and the code runs through all of them, there will not be any swaps. And once that happens, we can stop the code. So until swaps is equal to false, and we can end procedure. Okay, last bit of the paper. Let's go. Two 1D arrays were described at the beginning of the question. Both arrays contain 500 elements. This is like a recap. So yeah, two arrays will be replaced by a single array. A user-defined data type has been created. Type. Okay, so we're just trying to make one single array to represent both of those. Now we have to find the error in the record declaration, and yeah, simple. Error code is integer and not string. So error code should be integer type. Yeah. State two benefits of using a single array. So it is very convenient, but okay. So it is easier to design, program easier to design is one point. Design or even maintain, right? Next, okay, using a single array of a user-defined data type. So user defined data type, which means that we can store mixed type of data. So multiple data types under single identifier. Last one. Write the declaration for a single array in pseudocode. Simple. Declare. So I just called it error, and the array is of 500 elements of, now the type they have given, is it given? Yeah, error rec, that is our type. And that's the end of this paper. So thank you so much for watching. I hope you enjoyed this paper as well. If you haven't hit the subscribe, please do that. And I'll see you with some conceptual videos as well. Drop down in the comments if you have any specific topics you want me to cover, and please hit the subscribe. It really helps me a lot. Thank you. Bye bye.